everyone. So yeah, I think we will continue our work today on the learning Godot stuff. So yeah, I still working on this action RPG tutorial. So it's right now. I stopped on the step with the heading the grass. So yeah, let me show you real quick what's going on. So yeah. So we have walking, we have some collisions here, we have tiles with collisions, we have you see we have some like fighting stuff, attack, but yeah, I'm working right now on the script to actually as you see, when I just pressed the attack button, all grass just disappeared. That's how it shouldn't be. I mean, not all of them should disappear. So yeah, we'll continue right now. I need to turn off music. Yep, and now I will start the let me do one thing real quick. I need to see the stream, so to pop this small window. Okay. Yeah, I need to start the tutorial. You should see it now. Yeah. Okay. Let's move on then.
Animated sprite. What kind of functions do we have? We have play with an animation. We have stop, and we have if is playing. So those are kind of the functions we can do. We've got these different properties we can manipulate, but we don't really need to worry about those actually. So all we're going to do is inside of our grass effect in the ready function, we'll call animated sprite.play animate. And then we can run the game. Well, actually, we don't want to run the game. We want to run this specific scene right here to make sure that this is working. We can do that by pressing this little button right here or hitting F6.
No.
And I couldn't tell if it actually played. Animated sprite play. We didn't get any
I'm not sure.
error messages. Let's do... I want to be able to test this. So we'll do a process function. We'll say if input.is action just pressed attack. And then we'll copy this line right here and paste it right here. And run this scene. And now if we press the space key, it should animate, but we're not seeing it animate. So something is wrong here. Maybe we have to have playing.
I assume it
true.
wouldn't work for me as well.
Let's turn on playing again. Try this one more time.
Where you found
We're still not getting it actually playing. So I'm guessing the problem is since we're not on loop here, it actually is playing it whenever we do that, but it's not starting on the last frame or on the first frame. It's starting on the last frame. That's my suspicion here. So let's see if our play function takes some sort of properties. So we've got backwards. We pass in the string here. So it has a frame that it is set to. The default is set to 0, but we might need to reset that frame. So let's try doing that real quick. Animated sprite.frame equals 0. So we'll see how this goes. Let's see how this goes. And there we go. Now it's working properly. So essentially it was playing, but it was starting on the very last frame. So what we want to do here is set our frame equal to 0 right in here. We can get rid of that code now. We don't need it. So once this is created, it will start on frame 0, and then it will animate our sprite. And then what? Well, we want to get rid of it, right? So it animated there. It's hard to see, but it did animate there. Well, we want to get rid of it, but we don't want to get rid of it until the animation is finished, till the animation is over. And this is where signals come in. So on our animated sprite node here, if you click on it, instead of having inspector, come over to node, and you should see these two tabs called signals and groups. We're not going to worry about groups right now, but we do want to worry about signals. And you can see under the animated sprite, we have an animation finished and a frame changed signal. So these signals, they're basically signals that they're kind of like messages that get sent out, like a text message or something that gets sent out whenever something happens. It says, hey, this thing happened, like your friend has a baby or whatever. He sends out a message to everyone and says, hey, I just had a baby, right? That's kind of what it's like. And so we've got animation finished here. This signal is the one that we're concerned with, because once this animation is over, we actually want to destroy our grass effect. So we're going to double click on this animation finished signal, and it will open up this window, and it says connect a signal to a method. So this is a little bit scary looking. Signals can be scary, but basically whenever a signal fires, you want to connect that signal to some sort of function or method, so that when that signal happens, when the text, see, it's opened up our grass effect.gd script, and it's added this function. So now icon in the editor for the signal that we connected. And if we click on signals here, we can see that it's been connected. We get this information and the function it's been connected to. And we can double click on that, and it will bring us to that location in the code editor here. And we can also see that it's been connected here. We can see that this is a signal. We can click on that and get information that the source is the animated sprite node. The signal that this is connected to is the animation finished, and the target node that it's connected inside of is the grass effect right here. So let's run this scene again, see if this works. And yep, at the end, it actually gets destroyed. So one more thing we're going to learn about here is actually instancing nodes in code, or instancing scenes in code, because we know how to instance a scene inside of the editor here, right? We've done it before. We clicked on the grass, drag, you drop it in the editor. Well, how do you create the effect, right? Our grass effect inside of the game while the game is running, because we want to create it when our grass dies. So let's come into our grass script here, and we're going to create our grass effect scene right here inside of this grass.gd script once the grass is destroyed, right here once it's been attacked. So first we need to create a variable, and we'll call this grass effect. And I'm using a lowercase g here. I'm using camel case here, basically a lowercase g here. And that's because generally with my scenes, I name them with an uppercase here. So this is an instance of a scene, so I'm naming it lowercase here. Well, actually, we're going to load the scene first. So let's do uppercase. Ironically, grass effect equals load. And then we need to pass in a path for the scene that we're going to be loading. And well, we want to load our grass effect. So that's going to be under effects, grass effect.tscn. And it'll be under this path right here. Okay, well, that's kind of a pain to type out, but in Godot, you can actually come into your file system, go into here, find the grass effect scene, grass effect.tscn, drag and drop it right here. And that gives you the exact path to that scene. Okay, so once we've loaded this scene and stored it inside of this variable, we now need to create an instance of it. So we can say var
To be honest, this is weird
effect
loading of the
equals
like
grass
objects,
effect.
because basically I mean, I still like comparing with Unity. It's like a prefab, but can we just like create a I don't know, like variable and assign this effect to the node as a parameter? Yeah, because this I mean, load. Oh fuck! I just don't like it.
Dot instance.
Potentially, it could cause a lot of problems.
Okay. Now this is a little confusing because we've got uppercase grass effect here, lowercase grass effect here. Why? Well, this is the actual scene right here. This is called a packed scene. So it's a scene. It's not actually a node. But this right here, this variable is going to have an instance of that scene, which will actually just be a node, right? So it will be its own node, where this is a packed scene. It's a different kind of data. So once we instance that scene and store it inside of grass effect, well then, we actually need to put that grass effect inside of the room, like inside of this scene, right? So think about it this way. When we bring in our grass effect like this and drop it in, this node the scene gets instanced and then dropped inside of here as its own, as an instance of that scene. And we know it's instance because you can make multiple of them, right? But it has to be added as a child of some other node in the scene. It has to be added as a child. So we have to tell it to do that in code. If we come back in here, we can say, we could add it as a child of our grass that we're on right now, but we don't want to do that because the grass is about to get freed. So then it would destroy our effect. We want to add it to the root world node, or maybe our Y sort node. And that kind of depends on you, which one you want to add it to. But for me, I'm just going to add it to the root world node. So how do we get access to the root world node inside of our script? We can say var main equals get tree dot current scene. So this gets the current root main scene of our scene tree. Okay, and that's a little bit scary. It's a little bit hard to understand, but we can actually see this in action. So if you run Godot, okay, and then you come over here, you can see you have a local scene, which is the scene in the editor, but you also have a remote scene. Now this is the actual scene that the game is currently running. This is what the game actually looks like over here. You can see we have our world scene. We've got our background, dirt path, our Y sort. It's all this stuff. And if you click on these, like if we click on player and go to the inspector, we can actually see information about our player in real time. All of this stuff in real time this isn't the scene that we made inside of our editor. This is the scene that's actually running in the game right here. So if we actually move our player over here, we can see our player's position updating down here in the corner in real time. So we can see exactly what's happening inside of the game. So this right here is called our scene tree. So when we do get tree, it's getting this right here. And when we say current scene, so get tree dot current scene, it's actually getting the very first scene that it has right here, this world scene. And so that gets us access to world. So we can call this main, or we can call it world, whatever you want to do. Probably for consistency, I want to call it world here. So let's stop running the game. And that brings us back to here. And then we can say world.add child. And the child that we want to add is our grass effect. Now make sure this is a lowercase g, because this is the instance of our grass effect scene. You can't actually add a grass effect scene to the world node. It has to be an instance of it. Okay? And once we've done that, we can actually run the game and test this. So let's run the game and test it. Okay, so they all got destroyed here, and we got a grass effect, but maybe you guys saw it, maybe you didn't. It was actually up here in the top left-hand corner.
They all spawned.
Well, that's because
like
when the
position.
effect gets added to the world, it's being added at position 0, 0. So we also need to set the position. We need to tell it where in the world this grass effect should be. And we'll do that by saying grass effect dot position dot global position equals global position. Now this global position is the global position of our grass. So we're setting the grass effect global position to the global position of the grass. Now when we run the game and we swing our sword, we get the grass effect at the position of all of the different grasses. And that's the effect we want. That's the effect we want. So learning how to instance scenes inside of code is very important if you want to do anything inside of Godot. Like if you want to have a gun that shoots, this is step 2. Then you set its position to individual pieces of grass instead of just destroying them all at once with our overpowered move. Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to our Godot Action RPG series. This will be part 11, and in this video, we're going to be adding hurt boxes and hit boxes so that we can start attacking our grass. And in the last video, we set it up so that we had the grass effect that plays when we swing the sword for our overpowered move here. And one of the things that you guys mentioned, why make a brand new scene for this grass effect? Why not just put the grass effect inside of the grass scene right here? And that is a personal preference. So that's actually a fine way to do it. If you want to put the grass effect inside of the grass scene and have it not be its own scene, you can do that. I partially did it the way I did it in the last video for educational purposes, so I could talk about instancing scenes in code, and I partially did it that way because I actually prefer to do it that way. Now, doing it inside of here is going to make it slightly optimized, and if you have, if you have a game where you have 1,000 grass pieces that you can hit with some superpower move and it's going to make them all play the effect at once, you might be worried about that. And you might have a good reason for the optimization. Otherwise, you're probably fine without that slight optimization. So then at that point, it just becomes personal preference. Some people prefer to have it in the grass scene inside of here. There are some problems that come up with that method, which is if you put it inside of here, you're going to have to disable the hurt box of the grass while it's playing the animation, or else hitting it over and over and over again could play the animation over and over and over again. But that's not really, that's a problem that can be solved, right? It's not a big deal. So at the end of the day, it just comes down to which problems would you rather have and which do you prefer? The people who ask me that, I guess what I have to say to that is that that's actually a really good solution as well. And if you prefer to do it that way, then that's great. You can do it that way. It's a good way to do it. And I like to see people thinking about doing these things in their own ways, right? It's better for you to come up with a way. Maybe you prefer to do something a little bit differently. That's good. It's good for you to do it in your way and not always just do exactly what I say to do, right? I have my way of doing it, and I like it this way, and I have reasons for that. But if you have a different way of doing it, so this first one, we're going to call it hurt.
Whoa.
Okay, so this first area 2D scenes. Okay, so this first one, we're going to call it hurt box, and this next one, we're going to call it hitbox. Okay, you can save both of these scenes. This one's hitbox. We'll save this inside of, well, let's actually create a new folder here. I'm going to right click, do a new folder and call this hitbox hitboxes and hurtboxes. I don't know, that's good enough. And we'll save hitbox in here. We'll also save hurtbox in here. Now both of these also need their own area 2D or collision shape 2D. So we'll save that. We'll come into this one. We'll give it a collision shape 2D. And save that. Now we're getting a warning here. This warning says, well, you created this area and you have a collision shape in it, but you didn't actually create a collision shape. And that's intentional. And that's because we're going to be using these kind of as components or as reusable pieces that we can apply to multiple different areas of our game. And I'll show you how we do that. But this hurtbox and hitbox, they both use an area 2D, and I want to talk about what an area 2D is a little bit here. So an area 2D is a node that has to have a collision shape attached to it, but once it does, it can do some things like it can detect collisions, you can detect if the player has entered it, and if you look over at the signals here that we get, these signals will tell us a lot of the different things that we can actually do with this area 2D. We're going to be using these signals, like for area entered, in order to detect an overlap between our hurtboxes and hitboxes. So let's close out of both of these two scenes that we made, and we're going to come into our grass here, and we're going to click this little button right here. And what this will allow us to do is instance a new scene that we've made inside of this scene, and we're going to instance we're going to come into our hurtboxes and hitboxes folder, and we're going to do our hurt box on the grass. Now you can see that instance the scene here, but we don't have access to the children of this scene, so we can right click on it and we can do editable children, and that will give us access to our collision shape. So now we can actually set the collision shape for this. We'll do a new rectangle shape. We can set it right here and set this rectangle shape, and you can do it any size you like. I'm going to make mine slightly smaller so that it doesn't quite take up the entire 16 by 16 space, but now we have a hurt box attached to our sprite.
I like it.
Or our grass, I mean. And we can take this hurt box and we can say, okay, we want to be able to destroy the grass when this hurt box gets hit by a hitbox, right? When there's an overlap. And so we'll come into our node and we'll come into our signals here. And we can do the area entered signal right here. This area entered signal. We can double click on it. We can attach it to our grass. So now when this hurt box has an area entered signal on it with the area that is entering it, we can destroy the grass. So right here, we'll say Q free, right? And we'll actually take this code right here where we create the effect, and we'll make a function out of this. Function create grass effect. Okay, once again, if you have changed this part to where you have your own grass effect inside of the grass scene, you're going to have to make sure that you disable your hurt box, collision shape, or whatever, so that it can't be hit multiple times, and reset this animation that you're playing. Create grass effect. Unless you have a different way of solving that problem, but yeah, the idea stays the same. So we'll create the grass effect and we'll queue free. And so this is what the code inside of our grass scene is going to look like now. Let's attach a hurt box to our player. Let's come into the world scene, open up our player scene. Not a hurt box, a hit box, although we will be attaching a hurt box at some point. But let's start by attaching a hit box. Hitbox. Okay. I don't actually like the name of this right here.
Yeah, it looks disgusting.
Let's rename it here. I don't know. We'll call it overlap for now, because I don't have a good name for it. So when we come into our player, we have our hitbox here. Okay, we need to once again right click and do editable children so that we can create some sort of shape here. We're going to use a capsule shape for the hitbox on our player. I'm going to shrink this down just a little bit. And do something like that. Oh, couldn't save scene. Likely dependencies. Instances could not be satisfied. So maybe renaming the thing that we did was an oopsies.
The fuck?
Let's actually delete this hitbox and try and save the scene. There we go. That seemed to work. And we'll add a new overlap hitbox. We'll add another one again. Ooh, look, it remembered it. That's interesting. That might be a bug. Is this going to let us save now? It did. So that seemed to work. So if you have issues with that because of renaming this, you might have to delete the hitbox and recreate it there. I think that was a bug, but it's hard to say. I might have done something silly there. I don't know for sure. So now our player has a hitbox, but of course this hitbox just follows the player around. It should still work though. When we walk into the grass gets destroyed, which is kind of cool, right? Because it detects the overlap there and then destroys the grass. But we want to use our sword to destroy the grass, and we want it to be attached to our animations. So we can come into our animation player. Well, first make sure that your animation tree is set to not be active anymore so that you can come into your animation player and we can pull up all the attacks. And we want our hitbox here. We want to be able to rotate the hitbox to face the direction that we're attacking with the sword. So I'm actually going to create a position 2D node, and a position 2D is honestly exactly like a node 2D, except we get a visual indicator inside of the room for where it is. There's a little, if we actually hold Alt and click on it and move it, you can see this little visual indicator that node 2Ds don't have, but it's basically exactly the same. And you can change the gizmo extents, which just basically changes the size of the indicator, right? So, but we're going to actually position this at -4, and we'll call this hitbox pivot, I think. And let's see, our transform should be at -4. And this hitbox right here, we'll call this sword hitbox. Oh, I guess renaming it got rid of the editable children. Interesting. So let's open up editable children again. We'll attach it to our hitbox. That also got rid of the editable children. We need editable children to be on. And we'll set the sword hitbox to be, well, let's come into our animation player. And we're doing attack down. Let's set it to attack right. And then we'll zoom in here a little bit and we'll scrub to this frame right here, because this is going to be the best visual indicator of what our hitbox should look like.
Wait, attack right. Okay.
I've found that
But it's actually 2 frames. But anyway, okay.
good size here, and we can move this out right here to about there. So that position, So I accidentally moved the collision shape here. So we want to set its transform to 0, 0. We actually want to move the sword hitbox, and we'll set its transform to 0 in the Y so that it's right on our pivot, and then an X position of 15 I found. That works pretty well. And the collision shape, if you click on our capsule here, we're going to have a radius of 10. And a height of 12. So we get a pretty big collision shape here for our sword. Okay, so we can save this. Now, and this represents, so let's go over this again. We have our hitbox pivot. It's at position 0, -4. We have our sword hitbox. It's at position 15, 0. And then we have our collision shape, which has a capsule size of radius 10, height 15. That will give you this exact scenario right here for as long as your animation is set up like mine with your player position right where you're, because the position of your sprite is important as well, and mine is set to -9 in the Y and 0 in the X. So that's important to make sure this lines up as well, but you don't have to do yours exactly like mine. I just wanted to give you those values in case you wanted to. So then what we need to do here is we need to key the rotation of our hitbox pivot. So let's key this rotation, which is 0. And we actually want that key, I keyed it right here at this point, but we want that key to actually be at the start of our attack right animation. So I'm going to grab that key and drag it all the way over here to the left. Or you could just key it at this point. So let's go to the attack down, right? And which way do we want our rotation to be for attack down? We want it to be at 90. So that will rotate our hitbox so that it is facing down here where the sword will be swiping. We'll key this position. Now we want to do attack left, and we want to set our rotation to 180. That will face left, and we want to key this position. Create a key, make sure they're at the start of the animation, and then we'll do attack up, and we'll set our rotation to, you can either do -90 or 270, it doesn't matter, they both work. And we'll key this position. Okay, so that should work. Now we've got our hitbox attached to the player in the front of the player. So when we, like if I stand right here and then I do the attack animation, you can see that it actually swipes the sword and kills the grass. However, there's a problem. You saw it just there. So if I swipe down, right? Now the hurt box is actually below the player. So let's actually show this visually. We'll come into project, visible collision shapes, and show this like this.
Yeah, so we're not
and you can see
it,
now,
actually.
if I attack down, it puts the collision box down, but it's still active. So I can just walk into the grass, right? I can put it up, but it's still active. So I can just walk into the grass up here. So this collision box is set to being active all the time, and we want to update that in our animations. So let's come into our animation player, and you can decide which frame you want it to be active on. I like it to be active on this frame right here, on this very first frame of the attack. Not this one, but start on this one. So I'm going to come to our collision shape here, and we're going to key the disabled property. So key this, okay? But it's obviously not checked. We just keyed it unchecked. Then we're going to come to here. At this frame, I'm going to check disabled and key that, okay? So then it starts out active right here and then gets disabled at the end of the animation. And we'll do that with down as well. So we'll key it as enabled here, come over to this frame, check it, disable it, and key it there. Then we'll do attack left. Come over to this frame, key it enabled. Come over to this frame, disable it and key that. And then we'll do attack right. Same thing. Key it disabled. Now, you actually want it to start off disabled. Otherwise, when we start the game, it will be enabled. And so we want to just check disabled and save. So now it's set disabled by default. And now when we start the game, you can see that it draws it gray here and it actually doesn't interact with the grass. But the minute we use an attack, it enables it and positions it properly. Okay. And if we now come back into our debugger and turn off visible collision shapes, we can save, run the game, and this is going to feel a lot more natural for our sword swipe. Now we have hitboxes and hurtboxes enabled. Now there is a problem with this, and I guess I should probably go into it in this video. I was trying to decide whether to split it up into multiple videos, but I do want to address this problem right now. Because, you know, in this series, I introduce things in sequence, and so sometimes I'll do something because I'm trying to teach it, but then it actually introduces problems that we'll need to solve. And so the problem that we're going to run into here is actually that our hurt box right here, its signal gets emitted whenever an area enters this area, okay? Any area, that's the problem. So like, let's say we come into our world and we grab this piece of grass and we stick it inside of that piece of grass. You can imagine what's going to happen when we run the game. They destroy each other, right? Because it's any area that enters it. So even though we've labeled them hurt boxes and hit boxes, there's actually no way for the game to know when one of them's a hurt box or one of them's a hit box. So the solution to this problem, and we'll come back into our hurt boxes and hit boxes here. The solution to this problem is called, well, you could use groups, but I wouldn't recommend using groups. We're going to use collision, layers, and masks. You can actually set these to give them names because they start off as just layer 1, layer 2, right? But if you come into your project settings right here and you scroll all the way down to layer names and you do 2D physics right here, we can give these layers names. And so what I like to do is set up, first I have my first layer be the world layer. Okay, so that's where you would put anything that you want to be able to collide with, like a solid object. And then I like to have, sometimes I'll do a player layer. So, but we won't do that for now. We'll skip to layer 3 here and we'll do hitbox. And then for layer 4, we'll do hurtbox. And well, actually, I want to check my reference project on this one. Okay, yeah, I'm glad I checked it because I actually changed how I do this. For this project, I think I found a different way that I would prefer. So I have the world layer, and then I generally have a player layer, just in case something needs to detect the player. And then I have a player hurt box, and I have an enemy hurt box. And I'll explain why we only need these in just a minute. So that these are the 4 that we're going to create. So in project settings, under layer names, 2D physics, we're creating these layers, okay? World, player hurt box, enemy hurt box. Close. So what do we do here? Well, first off, I'm going to go into my hurt box and I'm going to check both of these so that there are no white boxes in here. So I'm going to turn off both of those. Then I'm going to go into my hit box and I'm also going to uncheck both of those. So they're not in either.
Oh, wait a second. It's disabling an area to decide here. Okay.
Then I'm going to go into my player and I'm going to go into the collision shape here. And for the player, we're going to want to set, where's our, oh, here we go, the actual player kinematic body. Come into your collisions here, and we want to put the player on. So the layer is the layer that you're on, okay? Think about it as in like you're sitting on the layer. So the layer is the place that you are, and the mask is the place that you're looking to. So we want to put this on the player layer, because our player is on the player layer, okay? We want to look to the world layer, and if you click on these little things over here, you can actually see them, okay? So we're on the player layer, and we're looking to the world layer. And this is for our player's kinematic body. That way, we can collide with the world. So then we come into our world here, come into your dirt path tile map. No, the dirt cliff tile map, and you can set the collision on this. So it's not going to be on the player layer. For this one, we can just set it to the world layer. This doesn't have to look to any other layers. It can just be on the world layer. That's fine. So our player is on the player layer. It rhymes. It's kind of annoying to say over and over. But we're looking to the world layer. If we weren't looking to the world layer, we would no longer collide with our walls, okay? That's how important this is. We need to be looking to this world layer. So our mask should be the world. That way we're looking to it, and then we can properly collide with these walls. So collision layers they were super confusing for me at first. When I first started learning.
Yeah, what is that? Is that the player? Okay.
World. That way we're looking to it, and then we can properly collide with these walls. So collision layers they were super confusing for me at first. When I first started learning Godot, I was like, I have no clue how to keep track of this in my head. So I finally...
Wait, what about like bushes, huh? What about bushes in the world? Let me check them. No.
came up with the system of the layer being the thing that you're on and the mask being the thing that you're looking to, right? So that makes it easier for setting up our hitboxes and hurtboxes. So come into our grass and click on the hurt box here, and we're going to say, okay, well, this hurt box will be on the, we'll choose a layer for the hurt box to be on. We want this to be on the enemy hurt box layer because it's going to be damaged by swords and anything that an enemy would be damaged by. In fact, you could think of this grass as a non-moving enemy. That's kind of how I'm thinking about it right now. So it's a non-moving enemy, so we're putting the hurt box on this grass to the enemy hurt box layer. Okay, that makes sense. Now let's go back into the player and come into the sword hitbox and come into collision. And we want to set the mask to be enemy hurt box because the player's sword hitbox should be looking for or looking to the enemy hurt box layer. Okay, so that's why I have it set up that way. Now, you can't just have any area collide with this grass. The only area that will actually trigger the collision now will be an area that is looking to or on. Oh, if it's on, is that an issue too? Just a realization here that might have been overlooked. Let's move this grass down here, save and run the game. If they're on the same layer, they might trigger each other still too. So no, they don't. They don't actually trigger each other. And so now this works properly, right? Only the hitbox layer, only something that is looking to that enemy hurtbox layer can trigger the collision. And the only thing that's doing that right now is our player's hurtbox. So in the future, when we make enemies, we will give them their own hitboxes, right? But we'll use the same hitbox scene that we've created over and over for all the hitboxes. However, the hitboxes on our enemies, they won't look to the enemy hurtbox. They'll look to the player hurtbox. Well, unless you want enemies to be able to damage each other, then you could have them look to both. And it's really easy. But potentially you just want them to damage the player, so you'd have them look to the player hurtbox layer. So the mask would be the player hurtbox. And there we go. That's it. So that is, like I said, it was one of the most confusing parts of Godot for me when I first started using it. But using the layers and masks is really important for optimization if you want to have your game nicely optimized, because then it won't even try and detect a collision if they're not in the proper, if they're not on the same layer or mask. It won't even detect them. But it is confusing, so don't feel bad if you're a little confused by it, and let me know in the comments if you need more of an explanation. Let me move this grass back up. There we go. And finally, I just remembered I do want to talk about this as well. So I have seen this has been an interesting thing for me in this series, okay? I have seen basically a divide in the Godot community as to when you should use process and when you should use physics process. So we talked about this in the last video. From the research that I've done, it seems that in the documentation, they actually tell you not to use the move and slide function outside of the physics process. And so my guess is that under the hood, move and slide is accessing the position of the character, and so it wants to have accurate data for that. It wants to wait until the physics process. But then I've had other people say that, getting input doesn't work quite as well inside of the physics process. So I would lean towards the official documentation personally, but there may be problems with this too that I'm not aware of. I don't know. The truth of the matter is I haven't noticed a problem with either of them. They've both worked fine for me. I think it's a little bit overkill for this example to get too deep into that. I'm going to go with the documentation and stick with the physics process here. And if you have reasons for using the process function, you can leave a comment below. I'll look at those. I take all of the comments seriously that you guys make. But once again, I'm going to stick with the physics process for this, for my example. And the main reason I'm going to do that is because of the Godot examples. If you go to see the official platformer game, the Godot platformer demo, it uses the physics process for the platformer demo. That's why I've made that decision in the end. It's such an easy decision to make. It's such an easy thing to change. So if you ever get new information, you can just change it later. It's not a hard thing to switch between these two. Anyways, thank you guys so much for watching this video. This was made possible by my Godot 1-Bit Godot course Kickstarter backers, as you all know.
Okay, moving on then. Yeah, it's part 12. How many parts do we have? Like 22.
Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to part 12 for our Godot Action RPG series. In this video, we're going to be adding in our roll state. In the previous video, we had our attacking in, but now I want to be able to have some nice movement with rolling around in the room before we start adding in our enemies. So we're going to come into our player scene, and we're going to come into our animation player, and we're going to start adding some new animations because we need all of our animations for rolling. So we're going to do roll, let's see, we're going to do roll down, new animation, roll down, and this is going to be 0.5. We're going to do roll down, we're going to do roll down,
New animations.
New animation, roll down. And this is going to be 0.5 long here. Wait. Yeah, that's right. I zoomed the wrong way. There we go. And we're going to come into our sprite. We're going to flip through our frames here until we get to roll. Here we go. Find roll down. Okay, here's the first frame of roll down right here. Key this frame.
I don't get it. Don't get it.
To our next frame. Key.
Don't get it. Okay.
Key, and key. Next frame. Key this frame.
Okay, it's 54. Oh, I mean 55 frame. 55th frame. And then next one, next. No?
Frame. Come to our next frame. Key, and key. There we go. Now let's create, we're going to actually save here. We're going to create a new function and we'll call it roll animation finished. Here we go. We'll say state equals move. Save. And at the end of our animation here, we're going to add a new track, call method track player, insert a key by right-clicking insert key.
Wait. Okay, so he's trying to add this roll. So we need state move. So we were setting our stuff back. This makes sense. Okay, guys, I will need to turn on music back and be right back. was quite a delay. Sorry about that. I'm back. So yeah, let me turn off the music real quick, and we will continue watching this tutorial and going through all the stuff.
And at the end of our animation here, we're going to add a new track, call method track player, insert a key by right-clicking insert key, and
Wait a second.
player. And at the end of our animation here,
It's roll down, right? Roll down. Does it look like roll down? Okay. Oh, hello. CBT Fullbar, good morning.
here we're going to add a new track, call method track player, insert a key by right-clicking insert key, and
You always forgot where to put. What to put? Okay, insert. No, it's something weird.
then
It's
insert
something
layer,
weird.
insert a key by
Oh, yeah, fuck. Okay, enabled function. Okay, a track. Call meet track.
add a new track, call method track player, insert a key by right-clicking insert key, and then search for roll animation finished and save. There we go. We don't want this attack to loop. And well, we do want it to loop for now because we need to we'll need to set it.
I forgot to save the script with this roll animation finished. Yeah.
It up in our animation tree. So let's add in roll left, new roll left.
Oh, CPT is captain. I didn't know that. Captain Fuber. Maybe it's Faber. I don't know. Faber. But yeah. Captain. I didn't know that. CPT is a captain. I need to remember that. But yeah, thank you for explanation.
0.5. We'll come back here until we find the first frame of roll left, which is this one, frame 50.
Oh, hold on. Yeah.
There we go. Add a new track, call method track on the player, insert a key, roll animation finished, save. Now we're going to do roll right.
Uber, in case you watch Save Pride Ryan. Saving Pride Ryan. Yeah. You should know what it means. Fuck, I don't remember. Like I was watching it first time when I was like really small, and then last time I was watched it was like maybe 2 years ago. So to be honest, I don't really remember. But let me Google that. Nope. Still have no idea what Fuber is. I see there is a lot of. I might know why. It's because I was watching it in how it calls, like not in with not the original movie, like with original English sounds. It was I was yeah. Just search for the Fuber. Okay, let me search. It's film. Jeez, what is this? Who these guys? And then okay, okay, that's hard.
Here we go. 40. Create. Oops.
Yeah,
Let's move this frame all the way back to the start. If you accidentally key it in the wrong spot, you can move it. Make sure we turn on that there. So we've got roll right, or looping, I should say. We'll come to this frame.
what's the frame? Frame 42. Is it really 42 or
Uh-oh. I accidentally
41?
keyed on the wrong frame there. Okay.
Okay, it should be 40 then. Yeah, like this. A military term for when a situation is FUBAR. It means it went completely wrong. Okay. Yeah, now I get it. Yeah. It's a nice little situation. Yeah, the reason why I didn't heard it probably because I was watching this movie with Ukrainian or Russian dubs, so it like changed everything. So yeah, maybe it was something different, but yeah, that's a cool name, Captain Fuber.
Key, 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 key.
Wait, what?
Key. Okay. So you should have it start here on frame 40 and then go to frame 44. And the very last frame here, we're going to add a new method track animation as well. And let's see, the only one we haven't done yet is roll up, right? Come in here, find roll up. Here's the first frame of roll up.
Also, it is a play on 1000s of beginner coding tutorial that use FUBAR, which is probably based on FUBAR. So, yeah, I can tell you some. I know FUBAR, like the really old music player. I was using it after Winamp, so it FUBAR, yeah, that's the player. So this one is a software. Is it still alive though? Yeah, it's Winamp. Yeah, Winamp after Winamp. Like, oh my god, they still have releases. Jesus Christ. Anyway, and there is some stuff that I'm working on my work. So when we need to deploy some new infrastructure, and all our infrastructure is used in templates. So to trigger a new build, I usually use a variable foo with a value bar to trigger it. And so I trigger it. This way I can deploy the application. After that, I need to delete it and to trigger it one more time. So it checks like the availability of new variable in the configuration, and it thinks like, okay, in this case we need to redeploy. So yeah, weird stuff. But I didn't know like it's still working. The latest release was 15 days ago. That's insane. Anyway, yeah, good old memories.
Here's the second one. Key.
So what's the initial frame? 44.
Here's the second one. Key.
Wait, I need.
Here's the first frame.
Okay, it's 45. Yep. Okay, and then we need to call it's the key about this roll stuff.
Here's the first frame of roll up. Call method. All of ours. Set this to loop. Now we can go into our animation.
I need to set these loops everywhere. But why we need the loop? Oh, really? I heard they was trying to like rebuild it or remake it. They even opened the website for the new version, but I thought it will be like I don't know, some streaming stuff like Spotify or something like that, but like from Winamp. It would make sense at least. But integrating NFTs, oh. Yeah. Oh, that's sad. It looks like, I mean, for me right now, every company that tries to like implement some NFTs, they just trying to make some money. So we're gonna sell you some shit to just make some money. That's all we need. We we don't care about you. Like we literally don't care. We will sell you some shit. So we can just make some money. This is at least how it feels for me. Yeah. Yeah, that's true. I mean, probably not pyramid. I would. It's like the technology behind it. It's really good. Like, yeah, it has a lot of potential. But the NFTs, NFT could be used as a tickets or as like some voting stuff. Like, just imagine if you will have if every citizen of any country will have like a wallet which will be attached to the like ID or something like that, and this wallet, you will see that this wallet had a vote, and you can use this vote like just to send somewhere, and like it's a good technology to track and to be safe from this basically abuse of voting system. So it's a lot of potential, but for now, I mean, it's as always the scammers and some guys who just wanna run some money. They come to this technology first. So yeah, that's why we see this explosion of NFT stuff. And yes, blockchain could easily substitute third-party verifications. Yeah, I mean, maybe we just need to wait when this NFT stuff will blow up, and after that, like the real company will start working on some real stuff, and not of this like, oh, just buy this, I don't know, just buy these shoes and you will receive money for it. It's awesome idea, yeah, money for walking in your shoes. This is so creepy.
Tree here, and we need another state.
Yeah, I forgot what I was doing.
Now we can go into our animation tree here, and we need another state inside of our animation tree. And we're going to have this connect to idle as well. So we'll create a new blend space 2D. We'll call this roll. And we'll connect our idle to this. So we'll have our, click on transitions, we'll connect to idle and then back here. So we've got transitions between the two. And we can come into, select our roll and edit it. And we'll make sure to set the blend to the little dots. Let's see, it's inactive, so I want to set our animation tree to be active so that we can see these updates.
Hold on. I lose a lot. Okay, roll now. We need yeah.
Click on transitions, we'll connect to idle and then back here. So we've got transitions between the two. And we can come into, select our roll and edit it. And we'll make sure to set the blend to the little dots.
I think I created something wrong. It shouldn't be blend tree. I think I created a blend space 2D. Jesus. The hell?
Blend space 2D.
Okay. Shit. Blend space 2D. Wrong. Finally.
And then into, and we'll make sure to set the blend to the little dots. Let's see, it's inactive, so I want to set our animation tree to be active so that we can see these updating. We'll come to add some points. We'll add one here, add animation, roll left, add one up here. Oops. Before we add one up here, we want to change this to 0.1, this to negative 1.1. Then we can add it up here, add animation, roll down.
Oh, come on.
Add animation, roll right. And then down here, add animation, roll up.
No. Okay, it works at least. Okay.
And then we'll switch back to this and we should play our roll. So come back and press the little auto thing here to play idle again and turn off our animation tree so it's no longer active because we activate it in code. Come back into the animation player and make sure to turn off loop on all of these roll animations so they no longer loop because we don't need them to.
Yeah, I was thinking why he adding the loops, but it was
And
just
then we
for
can
test.
set our animation back to our idle state here. Okay. So now we've set up our animation tree. We need to come into code and make sure and set the blend position on our rolls. So we're going to do it in the same spot that we do everything else here. We'll call this roll blend position. Okay? Inside of our move state. Now we already have our roll state here, but let's create a function for it, and we'll create it in between here, in between our move function and our attack function. Roll state.
Yeah.
It'll take delta, and then we'll just do pass for now. Now we need a transition to this, just like we have a transition to attack. So we'll say if input dot, well, let's create an action for this inside of our input map. So come into project settings, input map. We'll create a new action called roll. And we can add a key here. So I'm going to do the K key. And then let's do the Z key. And I'm not sure I actually like space for our attack anymore. I'm going to take that off. And I'm going to do X. So if you're using the arrow keys,
Oh, he's using the old input vector method.
then X will be attack and Z will be roll. But if you're
Oh, you mean like get this input is action just pressed, or? Oh, okay, yeah.
using WASD, then
I think they updated it in. Oh, you mean here, the define 36. So get axis and get the vector. Yeah, that's. I don't want to change it, to be honest. Don't want to spend, but yeah, get access to get the input vector on an axis x or y, and get the vector to get both axes. Okay, let's get the axis negative. Negative action, positive action. Can get access input by specifying two actors, one negative and one positive. This is a shorthand for writing. Oh, okay, so it's like just one. And get action string and get action string. Okay, okay. So in this case, I think we can replace it like this, and UI left, and we can remove this one. Wait a second. No, get access. Ah, yeah. You mentioned get axis and get vector. What about get vector? Oh, okay, so just, and it will return a vector. So we can assign just like one negative x, positive x, hold on. turn it, and I will just place it like this. That or and then so this is for the X, and then UI left, and then UI down, I assume, and then a UI fuck UI up, and this should work actually. Let's test it. Oh no, you don't like it. Why? Oh, okay. No. Okay, it goes wrong directions. Like when I press up, it just goes down. So I need to swap them. So like left here, right here, up here, and down here. Yeah, this should work. Up, down, left, right. Yeah. Yeah, this one works better. Yeah. Nice, nice. Thank you. Thank you, Captain. That was really useful. Okay, what about I added? He also added Z. Okay.
Then J will be attack and K will be roll. Close that, and then we can have our transition here. We'll say if input.is action just pressed roll state equals roll. So we're changing to our roll state. We need to make sure and call.
Oh, it gives you the normalize after. So I don't need to run it like this. Nice. That's nice. It's actually so easy, like one function and give you all the input right away, so you don't need like to do anything. That's nice. First roll.
All our new roll state functions. So roll state delta. Okay. And this will properly set our state. The problem here is that once again, our state doesn't actually do anything. So if we switch to our roll state, we just kind of get stuck there, animating, can't do anything about it. So let's actually make our roll state function do some stuff. Let's drag our output down and get rid of it here. And the first thing we'll do is set, well, we're going to need a roll vector variable. So we'll come up here, we'll say var roll vector. Now this variable, we need to store our roll vector inside of our move state. So basically what we're going to do, this will allow us to roll.
Hold on.
We need to store our roll vector inside of our move state. So basically what we're going to do, this will allow us to roll in all of the directions that we can move in. It will remember the direction that we're moving in, basically our input vector, and it will allow us to roll in that direction. But it only remembers it only sets that roll vector while we're actually attempting to move. That way you can't roll in place. So if your input vector is 0, then it won't update this roll vector. So we actually don't want our roll vector to start out at 0. We want it to start out facing the direction that we're facing, that the player sprite is facing. And currently we're facing down. So we're going to set this roll vector to down. Vector 2 dot down.
What? But what do you know
Okay.
down?
And then inside of our input map here, we're going to set our roll vector. So we'll say roll vector equals input vector. But we only do this if we're not 0, right? Because if our input vector is 0, then if we press the roll key and this will be set to 0 and our character won't roll, they'll roll.
Oh, okay, I get it. It's like for default when you need default state without any inputs. Oh, not velocity. Hold on. So, yeah.
In place, which is what we want to avoid. But if we update this only when we're moving, then even if we stop moving, the last time that this gets set will be the direction we were moving in before we stopped. So then we'll remember the direction we were moving in and roll in that direction, or essentially the direction that our character is facing. And that's what we want here. So once we've done that, we can come into our roll state and we can say velocity equals max. Let's see, where do we set our max speed? Velocity equals roll vector times max speed. And this roll does.
I was looking like, what is wrong with this variable? And then I noticed that I just used camel case for the naming. Yeah.
Doesn't have any sort of a
roll vector multiplied by max speed.
This roll doesn't have any sort of a acceleration to it. It just instantly reaches the max speed the minute you press the roll button. Now this is our normal max speed, and we want our roll to be actually a little bit faster. So we're going to do max speed times 1.5. The other thing we could do actually is to create a roll speed constant up here. And I actually like that idea more, so we'll create a roll speed, and we'll set this equal to 80 plus 40 is 120, so maybe 125. Will be a little bit faster than in my other one. And then we can come down here and multiply by roll speed. Roll speed. I think that's a better plan. And we need to make sure we update our roll animation. Update to our roll animation in here. We'll say, let's see where. Here it is. We'll say animation state dot travel roll. And we should be able to save, and this should work now. Oh no, we forgot one last thing. The problem now, why are we rolling in place and then we have some momentum afterwards? Well, it's because we're not actually calling move. So we have our velocity equals move and slide. I actually want to create a function for this where we update this. So we'll create a new little function down here. We'll put this between our attack state function and our roll animation. Call it function move. And this will take, does this need delta? I don't think it needs delta. It doesn't need anything really. So we can just say, copy this into here. So velocity equals move and slide velocity. And then up here in our move state, we can just call move. And then inside of our roll state, we can also call move. And that will allow us to easily call that inside of any state. And
what was that? Oh, this is kind of weird. Well, okay, that's not bad. But yeah, speed hack is working. You just need to press all the time, and here it is. Nice, nice, nice.
Trying to decide. I don't think I like the sliding.
Yeah. I think it would feel nice if we will just block these
Yeah, I don't like the sliding.
sideways.
It's too much to have it slide that much.
Yeah, yeah.
So we can set it to not slide at the end of the animation. We could, inside of our roll animation finished here, we could set velocity equal to 0. And that should fix the sliding, I think. But that's a personal preference. Maybe you like the sliding. It does feel pretty jarring. I wonder if we just halved our velocity. And we gotta fix that because we apparently
like
face left, not down.
Like this way.
Having the velocity
I don't have a
feels
controller
interesting
right
too.
now here, so
I
I
don't
have
know.
like some from the
I'm
PlayStation
not sure what the
4,
best solution
but
here is.
not here, so it's useless.
In my reference project, we don't
connect it.
have any sliding, and
But yeah, let me check. So is it that easy? Like for example, roll, joy axis, joy button. How to? Oh my god! It have like nice. This is nice. All you need. Awesome. This is really awesome.
I've definitely changed some things along the way, so I'm not necessarily sure what exactly was different. Oh, that's gonna kill me. We gotta make sure and set our roll vector to left here. Left. There we go.
So it's not down then.
So yeah, I'm not sure exactly what was different. Maybe it is just the actual speed that I set it to. Like maybe I need to be setting my roll speed to not quite as fast, so 120. That seems like a very minor difference. Maybe my friction's lower. That could be it too. I've got a much lower friction. I don't know, maybe the sliding isn't too bad. It just feels like we travel really far in our roll.
I don't know.
You're committing to a lot of movement.
Delta is not
if you try and turn around, you kind of slide.
He plays it.
It's a big commitment.
Every time. So maybe
I don't know. It feels kind of good later. Actually. The more I get used to it, it was jarring at first because I wasn't used to it, but I think I like it.
But for now, it's not needed at all.
And I still think if you wanted to reduce it, you could have it reduced here in the roll animation finished. Just set your velocity to something like velocity equals velocity.
Yeah, if you want to ignore the warning about method parameters, just add before the variable. You mean like here? Oh no, okay. I think we're yeah, here is delta needed. Nice, thank you. Okay, it's still showing me one error though. I like it. Argument error is never used. Oh, this one. Yeah, no errors, no warnings. Nice. Nice. You have a good knowledge about Godot. What are you working on? Are you working on some stuff with Godot?
Times 0.3 or something. And that would
Okay. Quite short answer, but yeah.
that would give you. Well, that's too jarring.
Do you plan into, like, I don't know, participate in some game jams? There will be one from Pirate Software in 10 days, I guess.
Too.
Because I even started learning Godot because I wanted to use Godot for that. But yeah, then I remembered that I have a vacation right in the same time when this. I think it's what is the time limit? I think it's 2 weeks. Let me open it. Oh, you will see it, two windows. Anyway, game jam. So it's from 15 until 29, so it's like 2 weeks. No, not 48 hours. I also hate this kind of jams. It's really short. Like, you need to do a lot of stuff. Yeah, but most of the time I will be on vacation. So yeah, you should try.
Let's try 0.8. So then
Roll animation finisher.
our velocity is 80% of our. Yeah, we get a little bit of a slide there, but not too much of one. So you guys can decide that kind of what you want this number to be right here.
I actually
And maybe
like
you
it
just
when
set
it's
velocity.
stopped.
Velocity equals. Yeah, don't slide a ton, but we do. For the one big thumbs up, subscribe to my channel. I'm gonna be doing.
Okay, and yeah. Yeah. But there is no limitation to press the button one more time. So, for example, I have so after all animation finished, the speed goes 0. So, and in this case, it stopped. But you can press it one more time, and this will increase the speed. Still, so all your speed will be like 100 125 for all of the times. So yeah, I think the speed hack still exists. You just need to press more now. Okay, I think, yeah, my time is running out, so I will be finishing the stream right now. So yeah, thank you, Captain Fubar, for being here. It's really nice. And yeah, hope to see you soon then. Yeah, have fun too. See you.
Mission 41B, the first flight of the orbital Discovery, and the shuttle has cleared the tower. Discovery's 4 computers now have